Haddad. Work with Patrick, Christian, Rachel. So I'm an evangelist. You may already be following me on Twitter and not even know who I am. Well, now you've met me in person, kind of exciting. So what I'm going to be talking about right now is how. Yeah, this is thrilling for me. How does DSE make you a badass? You being the customer, right? What are we actually delivering that makes them so awesome and look good in front of their boss? So the thing that I'm going to be talking about is high availability. Now we talk about this a lot, right? And it has this nerdy definition, right? We've got information technology. High availability refers to a system or component that is continuously operated for a desirably long length of time. That's too much. I actually choked while trying to say it. The easy way to say this is always on, okay? And this is part of our statement. This is one of the things that we think is really, really important. Always on, you could also say, is never off. Now that's something that's very important because there's a lot of systems that claim to be highly available. Unfortunately, they're kind of full of shit, and I will talk about why this is true and why we do something, why we are always on, and why basically everybody else can't live up to that claim.
May I pause you for just 1 second?
Yeah.
Because you failed my first question.
Okay.
So it's important to understand, John came to us. He was a customer before he came to DataStax. Not only that, he was a MongoDB user, or loser. What did I say?
That's true. No, we lost.
Who then migrated from MongoDB to Apache Cassandra, and then he came to DataStax. So John, and especially if you're in sales, John has real-world knowledge and experience of this journey in production at customer sites, and there aren't many people. So when he talks to you about how does DataStax Enterprise make your customers bad asses, then
sounds so much better with a British accent, doesn't
it? you really should listen to this.
Yeah.
He speaks from the other side.
And to that point, this is, I was the person that brought Cassandra into Shift, my last company, and we had a lot of problems with performance on the Mongo side. I brought Cassandra in, and basically all of our issues related to our database went away, and so I was the badass, which was amazing.
So we have really an analysis after lunch, though. So save the good stuff.
Yeah, Cassandra enabled me to be a badass at my company. I solved a lot of problems that a lot of people struggled with. I'm going to be talking about some of the problems that it solves on that high availability standpoint and why it works.
So you were like 120 pounds. Everyone beat you up. And then
Yeah.
you started using Cassandra.
Yeah, put on roughly 300 pounds
Bulked
after that.
No more sand kicked out failing.
So what do we, let's first start with how always on is possible, okay? And what we have is redundancy, right? We can't just have one of something and hope that it works all the time, because when it dies or fails, it's just out of the picture, right? So let's start with this. Like, what happens when we have just one of something, right? If it's on a plane or in a meeting, unavailable to us, we could say that this system always on? Well, maybe sleeping sometimes. What is the ideal situation? How do we solve this? Well, we introduce another one, right? So this is our redundancy. What happens if we have multiple available to us at all times? We really get to ask questions whether or not he's on a plane, in a meeting, whatever. This is our ideal situation here. We just want to keep making more abilities to be available to us. Can we have that? Probably not. Okay. Fortunately, in the computing world, we can get around this issue. We can have tons of things. We just build a lot of them. So let's start with one of the smallest components that we have and talk about how it fails and what that means for us in a database world. So the thing that we have in every computer that's a database is a hard drive. And a hard drive basically is this spinning pile of magnetically enhanced metal, right? And it's stored, this thing spins around, and there's this arm, and this arm actually moves around, okay? And it writes data back and forth. So whenever you're asked something from a database, this thing has to spin, this arm has to move, and it finds information for us. So like anything mechanical, it breaks down over time. What happens when things break down over time? They're just gone. So how do we solve this problem? we have more of them, right? So whenever we introduce more of the things, this is our redundancy, right? So we store data in 2 locations. If this one happens to fail, it's okay. We got this one as a backup. So over here we have our cluster. We actually have a running Cassandra cluster. Thank you, Patrick. And one of the things that's really fun about this is we can take a look at the drives, and they're all right here. So we've got these 6 drives, and so in our working Cassandra cluster, we can go ahead and take out the drive, right? And that's actually okay. It's totally fine. Our system will continue to work. We have one, where'd it go? Right there.
And John, what would happen if you unplug Oracle?
Well, if you unplug the hard drive from an Oracle box, the whole thing would just be a total disaster. It would fail. You would have
Errors.
massive data loss, errors. There'd be a whole bunch of problems. You'd have to restore from a backup, maybe. It'd be kind of a train wreck. So, any other questions on that besides Christian? No?
Why don't you show that it's all still up?
Do we have our
It takes
ops
a minute
on
to
our-
refresh. It's a Raspberry Pi. It takes a while.
Yeah, for those who don't know, those little computers up there are called Raspberry Pis. So if you've heard the term Raspberry Pi and you were actually thinking of a Pi, it's not. It's little tiny computers. Those are actually servers. They're just very small.
Very, very small servers. So
But
while
enough to run
Patrick's,
Cassandra.
so while Patrick's bringing up Op Center, which we're going to take a look at, it's going to show us the status of our cluster. We'll move on. Here's another technology that you may have heard of. It's called a solid state drive, usually abbreviated SSD. And this is more expensive than a hard drive, but is a hell of a lot faster. We're talking hundreds or thousands of times faster. I forgot what the exact number is, but this is a technology that is very common, and it's becoming even more common nowadays. So when you're using something like Cassandra, if you're taking a look and you're comparing, are you using, let's call this a hard drive or a spinning disk? You might hear Altobi refer to it as spinning rust, or a solid state. Solid state's going to be a hell of a lot faster, cost a little bit more money up front, but is in general going to lead to a lot better performance of your system. You can handle redundancy the same way that you handle traditional hard drives. There's a few caveats to this, but we won't really get into that right now. How's our
It's still taking a long
Ops
time.
still not updated?
Power of the live demo. That's why we don't do these at meetups.
I've even unplugged our.
Well, I mean, the rest of the cluster is completely up. I mean, you can
Yeah.
see everything's green still, right? Green light.
Green is good.
Green is good.
Green is good.
Yeah, that's right. And that's not the end of the destruction. Oh, no.
So what happens when you plug it right back in,
Well, this particular box.
or in the real world?
Well, that.
Well, okay, yeah. This one, I don't even know what'll happen. It probably won't do anything.
No, it'll come back online in about 10 minutes.
In the real world, if you have a Cassandra cluster and you bring a machine, let's say it fails for some reason, the hard drive dies, turn it off, and you turn it back on, it can rejoin the cluster, get any information that it's missing, and basically become whole again. So it handles failover very well in that regard.
It's usually a matter of minutes, right? Like less than an hour.
Yeah, it's going to depend on how long it's down and what the particular exact failure was, but it can, yeah, that's one of the things that makes it so great.
How quickly, like if I make a change on one drive, does it change all the other drives?
In this scenario,
Okay.
when we're doing something, when we're writing to 2 drives for redundancy, it's going to happen both at the same time. Yeah. So this isn't I'll show. I have my next thing I'm going to talk about is actually the kind of the next step above that. This is just if you have 2 drives in the same server. Speaking of which, the next thing that we're going to talk about is a server. Okay. There's a lot of components that go into a server, and yes, server's just a computer. Okay, it's got a bunch of components, has power supply, has memory, has hard drives. Thank you. All right. Not yet. Servers can fail too. All right. In fact, the more servers you have, the more likely you are to see a bunch of failures. It makes sense. If you have 1 car, your failures are going to occur infrequently. If you had 10,000 cars and you're driving them around all the time, you're going to have failure constantly. So let's take a look at how replication traditionally works with some of the databases that we've seen in the past. Like let's take MySQL, Oracle, things like that. the way that we handle data replication between servers is different than just individual hard drives. You've got your client, you've got this guy, this is me, you, whoever, and it goes ahead and it talks to one of these machines, and what happens is this machine then sends the data over here, okay? So this right here is what we call a single point of failure. Every single time we do a write, as our friend Rachel mentioned, everything has to go through this box, okay? So if that box goes down, you could have 100 machines over here receiving the data, but if this guy goes down, you've got downtime, okay? So now we've lost our scenario of high availability. So how does Cassandra handle this? Cassandra replication works a little bit differently. You can write to any of these machines, and then what they will do is they will replicate data throughout. So any one of these can go down. We're totally fine if we have any single node here fail. It does not matter.
Still green.
Ooh.
For any reason. They can read it.
What's that?
For any reason.
Thank you. So the next thing that we're going to talk about
Could have just gave it
is a
to
rack,
me.
right? So what is a rack? A rack is a collection of servers that are all together that are kind of performing the same tasks. You can take a whole bunch of machines, let's say we have these pies, let's pretend this is our rack, and we can take them and they'll be on the same network, they'll share some power supply, air conditioning units, things like that. But what's really great about this is if one of these dies, it's okay, you can swap it out, you can put a new one, it's a management issue. So if you ever hear people talk about racks, this is what you're looking at, a whole bunch of servers that are sitting all together. Now, what is a data center, right? This is our next piece of technology. It's a whole bunch of racks, okay? Now, data centers, there's a little misconception about data centers, and that it's because we have so many redundancies, we've put so many checks in place, we have fire suppression, we have locked cages, there's just tons of stuff that's taken care of for you. There's this assumption that data centers don't fail. This is not true. So for all the things that we can think about, there are a dozen ways that they can fail. So we can start with a fire, right? Small fire right here. We can have a really large fire. We can have flooding. These, I mean, it's not like I did this. This is real stuff. We can have ice age, maybe, that comes in. Perhaps army of monkeys. Alien invasion, all possible. Zombie attack, right? So there's a lot of things that we can't possibly prepare for in the data center, right? And you know, there's the idea of things that we can prevent. Love Smokey the Bear, only you could prevent forest fires. Even if everybody stopped doing, like leaving campfires going, you're still gonna have forest fires. It's gonna happen. So you're still gonna have data center failures in the same way. Can you plan for it? Probably not.
Still green. You might want to hit it one more time. It looks a little alive.
Yeah, the lights.
Really?
It's like Terminator, man. that did it. Oh, it's still alive. Dude, it's still alive. You drilled through the chip and it's still alive. All right, raspberry
this
pie.
is dead. Okay, this is dead. All right.
And it's still green.
So how can we survive full data center failure? By the way, all these are just jacked. Right? The idea is that we now run multiple data centers, okay? We want to write something over here in San Francisco, replicate to New York, and replicate it to Austin. And this is pretty sweet. Thank you. So here's the reason why I brought up why everybody else fails. Here's our list of people that you hear about a lot. You hear, these are some competitors. These are actually mostly taken off DB engine rankings. We got Oracle over here, MySQL, Postgres, Mongo, right? These are databases that people go to and they think they get high availability, but who actually does it well across multiple data centers? The reality is that none of these guys do. None of these databases actually work well across DCs. This is one of the reasons why Apple doesn't use Oracle anymore, right? For things like iMessage, right? They need us. They absolutely have to use Cassandra because there's no other technology that actually works well. Cassandra is basically like a cockroach, okay? If you have a properly set up Cassandra installation, you cannot kill it, okay? It will absolutely come back. It will survive the atomic bomb, no problem. So that's what I got. That's always on. So, questions?